Okay, so we're starting a new model. This is just a typical rectangular building, steel building. We're only going to do one story for now and then expand on that in the future. But it would be I guess, a three bay in the X direction and a three bay in the Y direction of different dimensions as far as the column spacings are concerned. And we'll add brace frames to each of the middle bays, and that will just be our typical, one-story building. Say the height will just to be um, a little realistic about it, definitely. So the first floor, we'll make the first floor about 15 feet in height, and as we build on that in the future, that first floor will essentially represent that lobby area that is typically higher than the other building floors. Okay, so here I'm using RAM structural system, and just so that we know what version we're using, here it is on the screen. I will not go through the details of it, but obviously this is a uh, version that was copyrighted in 2017. Today, by the way, is July the 2nd, 2019, and this is the latest version of RAM that I have on this computer. So I would say the first thing to do whenever starting a model is to start with let's go, you'll start a new file. So when you start a new file, you'll have this dialog box that pops up, and I will just put this in my tutorial folder, and I am going to call it 2017. I'm sorry, I'm going to call it July 2nd, 2019 personal tutorial of a standard building. I'm going to add a phase one to this actually. So when you start a new model in this dialog box, you have the opportunity to set the units. We'll be using typical English units, so-called imperial units, and that's it. You just give the file a name, select the units, save that file, and that initiates the process. This particular version of RAM is also cloud-based, and they will ask you to register the project or assign the file to a project. We're not going to do that for now, so we'll just cancel out of that box. Like I said, the first thing I think you should do, I always recommend, is that you go to the criteria menu and you take a look at each one of these applicable items. Here we'll select member loads. So this is the basic criteria for the member loading. We'll be using the International Building Code for our code requirements, among other things. In this area right here, obviously you can set whichever code that you like. Here, I'll be using, here's the opportunity to use either the snow or the roof live load. I like to use actually roof live loads, and I'll just input my snow loads as a load case for roof live loads, um, and then it'll be included automatically here. One of the main reasons I like to use roof live loads is because I typically consider all my roof live loads as unreducible, and they also have the same factors as the snow loads, so we're not losing any type of loading or gaining or penalizing the structure in any kind of way. We're not gaining any advantage as far as using this load unconservatively, so to speak. So all the factors are the same, and we'll go into the details of why someone would use snow rather versus roof live load. But for now, just know that I typically use roof live loads as the primary selection. Here, of course, I'm making my roof live loads unreducible, and this particular area right here is self-explanatory, which basically is asking you to include the story of roof levels in your live load reduction. And we could go into the discussion of this, but basically, the general idea is, do you expect the building to be fully occupied while there is also the maximum load or the design load applied to the roof? And just in general, again, I'm not going to take any live load reductions just in this case. It's a one-story building, simple, and I want to be able to easily track the loading. Here, combined beam loads will also be included in the reports. And we could go into the help menu right here to have any more explanation of this particular dialog box. All right. The other thing is self-weight. Okay. So here, I'm asking the program to consider all of the dead loads for beams, columns, walls, braces. Well, braces should be included, and we have to investigate whether or not that is included. I also believe, I do believe in RAM, actually braces are not included, but beams, columns, walls, slabs, and decks are included. And we could go into the help again to find out more information, but it's kind of important to note that the dead loads of braces are not included in the in the self-weight calculation of the structure, which is interesting. It should be included. So the next selection is the master steel table, which determines essentially the file location for the steel tables that you'll be using. By default, it's selected RAM AISC, which are your typical member sections that you will find in the steel manual, as well as some other member sections that are related to joists, I do believe. Uh, Design tables. So for the deck, we'll have these files that have pre-selected decks already loaded up into them, and we could just select from this like particular manufacturers. This is Ram deck. Uh, this is another. That's probably Can-Am. But I just leave all these defaults as is, and if I was curious as to what information is contained in these particular sections of the software. Again, I go to the Help tab, but typically this is all the normal stuff that we use here in the US, and there's often very little reason to make any modifications to this particular area. The defaults oftentimes work just fine. Again, for column selection, for design, AISC tables, beams, AISC tables. This particular is a castellated beam, and it defaults to the various tables that RAM has set up for castellated beams. Joist, for Steel Joist Institute, that's what SJI stands for, and There's no need to make any modifications here. And core braces, it's not really applicable to what we're talking about, but we can go into the help file, find out more information in this particular model. Again, this is going to be a very straightforward, simple model so that person can have the basic understanding of how to create models using RAM structural system. We'll get into the more elaborate stuff in the future. So the concrete tables here, ASTM for the reinforcement table is fine. It's also not the metric ASTM, it's just a US Imperial ASTM in pan form. Here, once I click on this, I get this message which says changing the reinforcing table will clear the concrete and foundation designs. Do I want to continue? So obviously, this is just telling you, it's prompting you and letting you know if you had previously ran an analysis, all of that design work will be reset, and you will have to rerun your analysis if you were to change the reinforcing table. So we don't have a need to do that. This particular model doesn't even have. I'm not going to create a concrete member other than the foundations. So I'm not particularly worried about this setting. I just leave the ASTM defaults, which is what we use in America. We'll cancel out of that. Let's see. And that's really about it. If you want to take a look at the units, you can. The other tables are related to non-American standards. And so we'll just take a look at the units. Like I said, it's set as English units, which is what we use when we started the file. Okay, so let's get to the nitty gritty. Just to look at the interface here, obviously we have the file menus across the top, the menu selection, there's file, there's criteria, there's models, design, post-processing, tools, view, help, Bentley Cloud Services. One of the things you might want to take a look at early on is just to click on these and see what happens, right? So this, once I click on that, it immediately throws me into RAM Modeler. I could exit it and get back to the RAM Manager screen. And that's what this is. So the top row is telling you which module, if you will, that you're in. And RAM Manager basically is the central database, if you will. So it's a central location that allows you to enter different modules rather, for your computer model. So here, model will take you into modeling. This is where you do all of the geometric and loading and boundary conditions. It's the main location for that information. Uh, Beam design, self-explanatory, but this is for gravity beam design mainly. This analysis, this module right here will only allow you to design gravity beams. Column design, self-explanatory. It should really say gravity column design because that's where uh, gravity columns are designed. Even though you'll have lateral columns and beams in your model, when these members are designed in these particular modules, beams and column design, it only takes into consideration the gravity loads that are imposed on your structure and not your lateral loads for earthquake and for wind or for notional loads or any other lateral load that you may have inserted into the structure. Here, RAM frame. So RAM frame design is the location where you do your lateral analysis, which includes both the effects of gravity and lateral design, lateral loads. or it should at the very least. And this is where we get into, the settings for P delta analysis, which are stability, which is a structural stability analysis and design. P large delta, P small delta is all taken into consideration at this location. Various things like the diaphragm settings are taken into consideration in RAM frame. Um, Also, the analysis method that is used for stability is taken into consideration, more specifically, whether or not you're using the amplified first order analysis, so-called B1, B2 method, or whether you choose to use the direct analysis method in your design. All that is taken into consideration in RAM frame primarily. Here, concrete design, again, gravity concrete design. This will take care of, my understanding is gravity columns and gravity beams. We'll look into it in the future, not for this model. The foundation design module, self-explanatory. We'll design the foundation. Here, spread footings, piles, pile caps, all can be designed within this module. We also have RAM concept integrated into this particular RAM manager file, which is used for slab design or floor design. This is the main area that's used for design of flat work, if you will. So it'll be slabs, and actually beams can be designed. Concrete beams can be designed in here. When I say slab, I'm talking concrete slab here only. Obviously, any type of metal deck that are filled with concrete, that's going to be designed outside of this system. And connections, of course, we can get into designing the connections, the steel connections, using this module, and that will essentially complete the bulk of our structural analysis and design. For this program, for this particular tutorial, we're not getting into any RAM connection design, any floor design, and we're not, like I said, we're not doing any concrete design other than the foundations. And that right there essentially completes the main modules that RAM structural system has here within this RAM manager interface. Uh, Other things like basically this generic graphic area gives you an idea of which software, well, which modeler, I'm sorry, which module you have ran, and whether or not the the module, the completion of the running of the analysis is 100% complete, or if it needs to be ran again for whatever reason because of changes that was made in one module, which may affect another module. So you'll see that these dots, which are light blue right now, will change colors, essentially go from red, gold, and green to indicate whether or not that module or the work within that module is deemed complete by the standards of this RAM structural system. Right now, light blue just means that nothing has happened in that area. Uh, Oftentimes, it's not applicable if nothing has happened in the area. It doesn't mean that there's an error or something like that. It just means that no action has been taken in that area. Um, Red means that you have to rerun something. Yellow means that that module also needs to be reran because something may have changed in another module which affected it. So you have to go back in there and rerun it, or enter that module and do some type of checks to ensure that your your particular settings within that module is still applicable. And green of course, means that all of the required settings and analysis procedures have been completed for that particular module.